Have you ever pondered over the impact the moon might have on our planet Earth? This question invites us to dive into a fascinating exploration of the intricate, dynamic relationship between our home, Earth, and its celestial companion, the moon. Our moon, a seemingly quiet, tranquil entity hanging in the sky, often overlooked as just a nighttime spectacle. But it holds an intriguing position in the cosmos that goes far beyond its silvery glow. The moon and Earth are like dance partners, locked in a perpetual ballet, each influencing the other in profound ways. The moon, Earth's closest celestial body, has been a constant companion for over 4.5 billion years. It's not just a silent spectator in the sky, it plays a significant role in shaping our planet and life on it. It's an integral part of Earth's story, and understanding this relationship is key to understanding our place in the cosmos. Imagine Earth without the moon. It's hard, isn't it? That's because the moon's influence is so deeply woven into the fabric of our world. From the rhythm of our days and nights to the ebb and flow of our oceans, the moon's impact is felt in countless ways. But the moon's importance extends beyond the obvious. It's a stabilizing force, helping to keep Earth's tilt in check, which in turn regulates our climates. Without the moon, Earth would wobble more than it does, leading to extreme climate variations. The moon also serves as a shield, taking a hit for Earth from meteor impacts. It's like a cosmic guardian, silently standing guard and protecting our planet. So, the next time you gaze up at the moon, remember it's not just a pretty face in our night sky. It's a vital part of our world, silently shaping our lives in ways we often take for granted. Indeed, the moon does far more than just light up our night skies. Did you know that the moon plays a significant role in how the Earth spins on its axis? Yes, you heard right. The moon is not just up there illuminating our night sky, it's also hard at work keeping our planet stable. Let's break this down. The Earth spins on an imaginary line called an axis that runs from the North Pole to the South Pole. This spin is what gives us our day and night. Now, the axis isn't quite upright, it's tilted at an angle of about 23.5 degrees. This tilt is what's responsible for our seasons, but did you know that without the moon, this tilt could vary wildly over geological timescales, leading to severe climatic changes? Here's where the moon comes in. The gravitational interaction between the Earth and the moon helps maintain this axial tilt, providing a stabilizing effect. Essentially, the moon acts like a cosmic anchor, keeping the Earth's tilt in check and ensuring a relatively stable and hospitable climate. But the moon's influence doesn't stop there. It also affects the speed at which the Earth spins. The gravitational pull of the moon causes a slight bulge in the Earth's shape. As the Earth spins, this bulge attempts to align with the moon, causing a slight tug on the Earth's rotation. This interaction results in what scientists call tidal friction, gradually slowing down the Earth's rotation. Over billions of years, this has had a noticeable effect. In fact, when the Earth-Moon system was young, a day on Earth was only about 5 hours long. Thanks to the moon's gravitational pull, the length of our day has been gradually increasing. Today, we have a 24-hour day, but in a few billion years, our day could last as long as 48 hours. So without the moon, our days would be significantly shorter. Fascinating, isn't it? The moon, our silent guardian, playing a crucial role in our planet's rotation and stability. Ever wondered why we have high and low tides? The moon is the key player here. Let's dive into the fascinating world of tides. Now, we all know that the moon orbits the Earth. But did you know that as it does so, its gravitational pull causes the sea levels to rise and fall? This constant ebb and flow is what we call tides. But how does this work, you ask? Well, the moon's gravitational pull is strongest on the side of the Earth closest to the moon. This pull tugs at the water, causing it to bulge outwards. This bulge is the high tide. On the opposite side of the Earth, the moon's gravitational pull is weaker, causing the water to spread out less, creating a low tide. Now, as the Earth spins on its axis, different parts of the planet pass through these bulges, experiencing high and low tides. So, in a nutshell, every day, most places on Earth experience 2 high tides and 2 low tides thanks to the moon's gravitational tug-of-war. But there's more to the story. The moon's position relative to the Earth also affects the intensity of the tides. When the moon, Earth and sun align during a full moon or new moon, the combined gravitational pull of the moon and sun creates exceptionally high and low tides, known as spring tides. Conversely, when the moon is at a right angle to the Earth-Sun line during the first or third quarter moon, the gravitational forces are not in unison, resulting in less intense tides known as neap tides. So, the next time you're at the beach, take a moment to appreciate the dance of the tides. It's a breathtaking ballet, choreographed by the gravitational forces of the moon and the Earth. Next time you watch the tides, remember it's the moon's influence you are witnessing. The moon, our natural satellite, does more than just orbit our planet. Its role in our solar system is far more intricate and important than merely being Earth's nightlight. Firstly, let's consider the moon as Earth's trusty shield. That's right, much like a superhero, the moon stands between us and potential danger: meteor impacts. It's hard to imagine, but without the moon, Earth would be directly exposed to a higher number of meteor strikes. The moon's gravitational pull acts as a magnet for these space rocks, drawing them toward itself and away from our planet. In fact, craters on the moon's surface are testament to its silent vigil, evidence of countless meteors it has intercepted over billions of years. It's a role that the moon has carried out diligently, without us even realizing the danger we've been saved from. It's like having a silent guardian, a watchful protector, a lunar knight, if you will. Now let's shift gears and talk about how the moon affects the amount of sunlight Earth receives. The moon doesn't have a light of its own, and the glow we see is actually sunlight reflecting off its surface. But did you know that the moon's presence also affects the amount of sunlight that reaches Earth? During a lunar eclipse, the moon passes between the sun and Earth, casting a shadow on our planet and blocking sunlight. This temporary darkness is an awe-inspiring phenomenon, a dance of celestial bodies, reminding us of the intricate cosmic ballet we are part of. But even on a day-to-day basis, the moon's orbit around the Earth, along with its reflective surface, slightly alters the amount of sunlight that reaches us. It's a subtle effect, but yet another way the moon plays a role in our lives. The moon, therefore, acts as a protective shield and a regulator of sunlight for Earth. It's our ever-vigilant guardian, silently shaping our existence from hundreds of thousands of miles away. Now that we've explored the various ways the moon influences Earth, let's wrap up. We dove into the moon's effect on Earth's rotation, revealing how this celestial neighbor subtly slows our planet's spin. This effect, known as tidal friction, results in longer days over millions of years. It's fascinating to think that without the moon's gravitational pull, our days would be a speedy 6 hours. We then journeyed into the realm of tides, understanding how the moon's gravity pulls at Earth's oceans, creating a bulge on the side closest to the moon. This gravitational tug-of-war results in the ebb and flow of tides that we experience on our shorelines. It's not just the oceans that feel this pull, but the solid Earth and the atmosphere as well, although to a lesser extent. And let's not forget the moon's role as our natural satellite, providing a stabilizing effect on Earth's axial tilt. This tilt is responsible for our seasons, and without the moon's steadying hand, the tilt could vary wildly, leading to drastic climate changes. Understanding these influences is not mere academic interest. It carries weight in our daily lives and the planet's ecosystem. The ebb and flow of tides influence marine life and their breeding patterns. They also aid in coastal cleanup by carrying away debris and pollutants. As for the moon's influence on Earth's rotation, it contributes to the stability of our climate, making Earth habitable. In a broader perspective, studying the Moon-Earth relationship equips us with valuable knowledge to explore other celestial bodies and their potential for life. It helps us appreciate the intricate balance that sustains life on our planet and the role celestial bodies play in maintaining it. So the next time you gaze at the moon, remember its silent yet significant influence on our planet Earth.